In this example, we have a NOR gate flip-flop. We know how a NOR gate operates, therefore we know this truth table. And we are given in the question that Q equals 0 initially. We're also given that the set signal varies from 0 to 1 over time, just like this, and the reset signal varies from 0 to 1 over time, just like this. We are also given that this flip-flop works on the rising edge of the clock, so it is triggered by the rising edge of this clock signal, so I put some arrows on it showing the rising edge of the clock. The question is, draw the output Q. So what you would do when you have a clock is you are going to draw, it's only valid where that clock signal rises. So it falls down and then it rises again, and then it rises again, and then it rises again. And a clock is somewhat a little bit easier because you only have to draw the output where the output only changes when that clock signal sort of opens the gate for that change to happen. So here is Q, and I said in the question Q was 0 initially. So Q is sitting at 0. And then let's look at what happens on the first clock signal. I have a 0 and a 0, and a 0 and a 0 out of this truth table says that there's no change. So I'll just keep going across and I can go all the way up to the next clock signal. No change. Because that's what our truth table says. Now at my next clock signal, there's a 0 and there's a 1. And when there's a 0 and a 1, so when set is 1 and reset is 0, then it sets this flip-flop. So set means Q goes to 1, and it has to last all the way up there at 1, all the way until we get to the next clock signal, because we don't let anything happen until it gets to the next clock signal. And then at the next clock signal, set went down to 0 and reset went up to 1, which means that we reset this this flip-flop. And when reset means Q equals 0. So we set it and then we reset it. And let's see, now that's valid until the next rising edge of the clock. Next rising edge sets again to 1 and resets down to 0. So I'm setting that flip-flop again. I set it. And at the next clock, it looks like we have a 1 and a 0. So it looks like we want to set it again. It was already set, but we're going to set it again. And so that's the answer of output Q from the NAND gate, the NOR gate SR flip-flop when Q started initially at 0 and was triggered on the rising edge of the clock.